In this video, we're talking about operations, multiplication, division, addition, and subtraction with complex numbers. So notice in example 6 here, I have z equals 3 plus 2i and w equals 4 minus I. Recall that the real part of z is equal to 3 and the imaginary part of z is equal to 2. So here I have 3, I have 2, and 2. And this is, if I want to know the real part of w, that's equal to 4. And the imaginary part of w is equal to -1. So the real part is 4, -1. All right, if I want to add these two together, I'm going to write z plus 2i, so 3 plus 2i, which is z, plus, and I'm going to put parentheses around that, plus 4 minus I. And I'm going to add my real terms and add my imaginary terms. So that gives me 3 plus 4 plus 2i minus I, which gives me 7 plus I. And there you have it. So the point here is to make sure you add your real terms and add your imaginary terms. That's A. For B, we're subtracting, so z minus w. So that gives me 3 plus 2i minus 4 minus I. I'm going to go ahead and just distribute this negative to both sides there. So 3 plus 2i minus 4 plus I. Now again, I want to combine my imaginaries and combine my reals. So 3 plus -4 gives me a -1. 2i plus 3i gives me a -1 plus 3i as your final answer. So again, in addition and subtraction, you just want to add and subtract your real and imaginary numbers. All right. Let's look at C for multiplication. I have z times w, which is equal to 3 plus 2i times 4 minus I. And this is just going to be like multiplying a binomial. So I'll do my first term, which is 3 times 4, 12. My outer term, 3 times -I, -3i. Inner, 2i times 4, so that's an 8i. And last is a -2i squared. Now, we can simplify this to 12 minus, and I'm going to combine these guys right here. That's a 12 plus 5i minus 2i squared. Now, we're going to pause here for a second because if I is equal to the square root of -1, then I squared is equal to, well, what's square root of -1 squared? -1. So if I squared is equal to -1, then up here, I squared, I can take -1 and plug it in there. And what we have here is 12 plus 5i minus 2 times -1. Okay. And then we simplify even further. So that's a positive 2. So that actually becomes 14 plus 5i, because this right here is a positive 2. So 12 plus 2 is 14. And there you have it. All right. And last, here I have z divided by w. Z divided by w. So that would be 3 plus 2i divided by 4 minus I. Now, in order to divide, what you're going to do is you're going to multiply. So I should back up here. Multiply by the complex conjugate in the denominator. And the reason we're going to do that is when you multiply by the complex conjugate, you're actually going to end up with one whole number in the denominator. Okay, and remember the complex conjugate is if I have a plus bi, z is equal to a plus bi, the complex conjugate, which is using that symbol asterisks, a minus bi, okay? So notice this is a minus, so the opposite would be plus, complex conjugate. All right, so then we're going to go ahead and multiply through here on top. I'll do that first on top. So that is 4 times 3 is 12. 4 times 2i is plus 8i. Then I have I times 3, it's plus 3i. And then an I times 2i, so that's plus 2i squared. Divided by, okay, 4 times 4 is 16. 4 times I is 4i. Negative I times 4 is negative 4i. Negative I times I is negative I squared. Now, we do some work here and simplify. So up top in the numerator, I've got 8i and 3i. And remember, guys, that this I squared, going back up to this problem right here, I squared is equal to negative 1. Okay? So if I were to simplify this top, I get 12 plus 11i, and 2i squared is actually equal to minus 2. Because I squared is equal to negative 1. Downstairs, these two go to 0, and I'm left with 16. Remember, this is a negative minus, and then I squared is equal to negative 1, so it's minus a negative 1. So, total simplification is 10 plus 11i over 17. And if you really wanted to, and this is what I expect actually, is you want to make sure you split it into the real and the imaginary. So the real part is 10 over 17 plus the imaginary part is 11 over 17i. Final answer. So when you divide, you multiply by the complex conjugate over itself. And that's operations with complex numbers.